Now let's look at our next topic, which is limitations of machine learning. Now, the first limitation is machine learning is not capable enough to handle high dimensional data. This is where the input and the output is very large. So handling and processing such type of data becomes very complex and it takes up a lot of resources. This is also sometimes known as the curse of dimensionality. So to understand this in simpler terms, look at the image shown on this slide. Consider a line of 100 yards and let's say that you dropped a coin somewhere on the line. Now it's quite convenient for you to find the coin by simply walking along the line. This is very simple because this line is considered as single dimensional entity. Now next you consider that you have a square of 100 yards and let's say you dropped a coin somewhere in between. Now it's quite evident that you're going to take more time to find the coin within that square as compared to the previous scenario. This square is, let's say, a two-dimensional entity. Let's take it a step ahead and let's consider a cube. Okay, let's say there's a cube of side 100 yards and you have dropped a coin somewhere in between this cube. Now it becomes even more difficult for you to find the coin this time because this is a three-dimensional entity. So as your dimension increases, the problem becomes more complex. So if you observe that the complexity is increasing with the increase in your dimensions. And in real life, the high dimensional data that we're talking about has thousands of dimensions that makes it very complex to handle and process. Now, the high dimensional data can easily be found in use cases like image processing, natural language processing, image translation, and so on. Now, in K-means itself, we saw that we had 16 million possible colors, right? That is a lot of data. So this is why machine learning is restricted. It cannot be used in the process of image recognition because image recognition and images have a lot of pixels and they have a lot of high dimensional data, right? That's why machine learning becomes very restrictive when it comes to such use cases. Now, the second major challenge is to tell the computer what are the features it should look for that will play an important role in predicting the outcome and in getting a good accuracy. Now, this process is something known as feature extraction. Now, feeding raw data to the algorithm rarely works, and this is the reason why feature extraction is a critical part of machine learning workflow. Now, the challenge for the programmer here increases because the effectiveness of the algorithm depends on how insightful the programmer is. As a programmer, you have to tell the machine that these are the features, and depending on these features, you have to predict the outcome, right? That's how machine learning works. So far in all our demos, we saw that we were providing predictor variables, we were providing input variables that will help us predict the outcome, right? We were trying to find correlations between variables and we were trying to find out the variable that is very important in predicting the output variable. So this becomes a challenge for the programmer. That's why it's very difficult to apply machine learning models to complex problems like object recognition, handwriting recognition, natural language processing, and so on. Now, all these problems and all these limitations in machine learning